Welcome everyone to another amazing low-level and high-tech latest and greatest state-of-the-art live stream. Today we will be working on the Rust compiler. Yes, not only the most amazing state-of-the-art compiler you could currently have with all the borrow checking for memory safety, and also the currently most hip, trendy and beloved programming languages. The only issue is that, unfortunately, with all the amazingness of Rust, the language and stuff, does not mean that all Rust code is amazing. Of course, you can still write shitty, imperfect, unsafe, and even logic error and bugs and stuff code in Rust. Case in point, even the freaking Rust compiler, right? Rick and Themia, yesterday's live stream. So if you're new to this channel, we run a Linux distribution for 25 years, so naturally we support everything from ARM to RISC-V. And yesterday, not only did we find that RISC-V 32-bit was not, for example, compiling cargo, but we also found that MIPS64 is doing some really strange stuff. And yesterday I struggled to find out what is going on here with Rust for MIPS64 not being able, this is slightly different, not being able to link that, because some file, do I still have this in the history, some of those files was 64-bit stuff for our, and because the complexity similar to x86 PowerPC ARM 32 64-bit variants, and in the case of MIPS, one of the first who innovated the N32 ABI, a 32-bit pointer with 64-bit and more floating point registers. Something similar that later was created as x32 for x86, 32-bit pointers for running in 64-bit mode with all the more general purpose registers and 64-bit registers. And something people have done in PowerPC and Spark or HPPA RISC in general for running simply 32-bit binaries in no special mode, no special ABI, just 32-bit binaries, because they anyway had 32 or so general purpose registers for better memory and cache utilization. So much the summary, right? So yesterday we wondered, like, what the heck is going on. I was randomly patching this spec file here. Do I have this in the history? That is that. I was yesterday randomly fiddling around here. Nothing really freaking worked. And I was like, what the freaking heck, that actually should freaking work here. And by the way, we probably can, okay, we do this later. So basically I was fiddling around here, like, why does this not freaking work here? And of course I continue to debug this, my famous couch debugging at midnight, and I realized, wait a second, all the other files, is that that? Oh, this was that, but all the other files there, we actually can simply, that turns out all the other files, so all my spec editing, there actually freaking works. TM with LVM as background, as Rust C is using LVM. Turns out all the other binaries are actually proper 32-bit N32 MIPS4 as you see here. So what the freaking heck is going on, right? Of course, last night at midnight I'd continue debugging at this stuff, like you do with this complex stuff as S-trace and so on, to figure out what is even freaking used to create this special snowflake ARM matter, Rust matter and library and stuff files. I thought naturally, I thought some LVM tools, but no, that is natively done in Rust. And the problem with that is I fall literally from my sofa. I had to grab the whiskey. I couldn't believe it. I wasn't disappointed. Like Rust does not. Rust continues to deliver, be in disappointment. Yes, I know I disappointed some people, but it turns out they implemented this themselves. Like they're not using LVM for that. They have here vendor object, which crate is it? So that is object, vendor object stuff. So they did their own freaking ELF implementation thing here, which of course they can do, just that this is not the most amazing. So like open coded, like I didn't even see that yesterday. Like I've done since 2005 in my exact image Enionist template stuff. Of course, not like you would have one Onion thing, like of course each crate has their own Onion stuff. But so MIPS, the problem is they just concatenate, they basically have their own ELF archiver here, Like, of course you implement the 20s or 30s or maybe even hundreds, probably counting all the Unix system, whatever, AT&E, SCO and AIX and Sun and Java and whatnot. Of course, in 2015 or whenever, they implemented their own ELF stuff and not using LVM. The only problem with this stuff is it's incomplete, buggy, and hard-coded. I mean, obviously you write the most amazing code in Rust, not the safest language, but if you write logic bugs and stuff, and then no surprise, it's buggy. Turns out, I couldn't believe my eyes last night, wherever that was, here somewhere, I believe in, it should have been in 030, oh wait, this is a wrong file, fix file, ELF writer, there must have been one other. Metadata, probably CodeGen. Is it that one? Source backend metadata. No, it was this one. You see, of course, it's spread and cluttered over all the sources. I believe here this looks familiar. So here, so I already modified this slightly. So yesterday this ABI2 wasn't here, and here was not Arch4. So basically, this was reading 64R6 and this ABI. So otherwise, you can look this up. This is how they literally write the bloody ELF header for these architectures, and obviously that is extremely wrong. Actually, we probably I mean, it's wrong, and hard-coded is like also copied, like 2020 or whenever, someone copied from mipsel linux gnu abi gcc foo-c. It's like, hey, quality computer science engineering at its finest. We create a binary, we read ELF it or hex edit it and copy the freaking values out of it. And you wonder that I'm not getting depressed, need code therapy live on my own channel. I slightly modified this already. This is not yet fully working. Also for MIPS 32, it's slightly more. I mean, this is how it, in general, I wouldn't say that this code is the most amazing, beautiful and amazingly written, but the Rust people will probably disagree. I would say this should be a little bit more generically implemented and not like some, also, I mean, I would actually define some struct and assign those values and, or actually there is some eflect, but actually also this is let eflect, or this is just some, yeah, but I would, in general, I would prefer some more generic infrastructure, but case in point, in Rust you can write buggy, unpretty, convoluted, open-coded code like you would in C or assembler. The MIPS 32 code is a little bit more complete. I mean, this is, I mean, again, it's not how I would done it, but at least they match here the target options for MIPS 1, 2, 3, 4, 5 and more, and R6 like you should do. And ironically for RISC-V, they handle both cases here. And I probably would say, in an ideal world, I would probably say this should be unified, because at least some of those, like from MIPS 4, I believe, was 64 bits, so MIPS 4, 5, actually 5 never was really released, I believe. Or was it, or is? Doesn't matter. So yeah. The problem is that is not all. So of course I slightly modified this. This is also why this file reads already slightly different than yesterday. Yesterday in our debugging session previous video, we have seen here this file, that this file was MIPS R6 release 2 or so, I believe. So it's already changed. So you see this has an effect that is the right code. By the way, this code took me 2 hours to find, right? You could say like read the freaking manual. Like obviously there is not a book for people writing, working on the Rust compiler, right? There is a Rust book for end users, but it's not like you find the freaking manual for like how some young and naive YouTuber adds new or fixes architecture support. I find this micro dependencies highly cluttered and convoluted. And sure, now that I've seen it, you can always say, it is so easy. Yeah, sure, after I debugged through the stuff for 2 hours at midnight, with some good whiskey at the end, because how should you otherwise endure this stuff? Of course, now after 2 hours at midnight, I'm more familiar with this code. Also, like, recurrent question, like, how do I know all this stuff? For 25 years, I debug day and night, stuff like that. So it does not fully work. It still outputs this as 32-bit. As far as I remember, this needs to be a 32-bit ELF file. The problem with 32 versus 64-bit ELF files is this was link format, what was it, extended, executable link. I always forget. Executable linking format, of course. Cheers. The problem is this obviously needs to be the right type. Also, by the way, pro tip. So also, how should this be better? I wanted to say, this should be better in that it should take, it's concatenating, it's basically archiving other object files, right? It should actually freaking read this bloody object files and extract, because all the others are correctly generated from LLVM. If they would not hardcode, I mean, besides this hard-coded code is shitty, it should anyway not be hard-coded like this, but take it from the bloody input object files. And even the 30-plus-year-old Free Software Foundation GNU bin utils obviously do the right thing. We have seen it yesterday. I mean, besides the segmentation fault, because they assert, which I also don't like. Although technically it is kind of sort of the right thing, except assert and segmentation fault is always like, is some binary stuff buggy. But the assertion was actually, in fact, asserting that the input machine object stuff were the same machine. So that would have been the much better thing. Also, actually, if you ask me what would be a recurring stream write previous video perfect code, and that happens, ladies and gentlemen, if you write imperfect, the usual YouTubers, perfect code is evil or whatever and expensive and stuff. It's like, no, imperfect code is expensive because it doesn't freaking work. It wastes hours of every developer touching this shit. And even more of refactoring, because in my opinion this needs a complete refactoring. This code is neither well written nor logically the most sound, because what it should do is, like other bin utils, even LLVM, reading the bloody object files, extracting the ELF metadata, and actually comparing it that they're all freaking the same, and reusing the bloody information, because they are even correct. So there would not be a hard-coded here like that, but simply read and reused. Then we wouldn't need to hard code this stuff to match what we probably should generate with LVM anyway. And yeah, as I said, it probably would be best to unify this, although maybe it gets a little bit convoluted, so it doesn't. I will probably just add that here. So basically we need to copy. So what we need to do now is write some state-of-the-art Rust code, totally safe and stuff, as you see, and copy this stuff down here, parts of this, and structure it a little bit. It's of course the biggest job of the world. So the only complication is that we also need to write 32-bit code. And as I just wanted to outline, 30-bit and 64-bit ELF files differ obviously in all the sizes of all the relocations and tables and so on, and symbols and everything. So all the values are 64-bit. And this is why I had the other file already. I found this also already last night at midnight. You can share, like, subscribe, Patreon and YouTube membership, and for all the hard work here. That was, I believe, also fix file, not just file. That was the other writer. I believe that should be this one, because obviously it is. That is also an object. Also, by the way, do we have do we have multiple? Don't tell me they have. Oh, they have freaking 3. I can't make this shit up. I didn't even see this yesterday. This is of course a recurring worst case, what I also extremely dislike for this Rust stuff. Not only 160 freaking micro dependencies, at least for the case of cargo. Probably Rust in the meantime has more. Some 2 years ago live on this channel, Rust had 150. Let me just open the library with different bugs and features in one freaking project. This is so silly. I have recurrently no words for that. So let's see. The other one I patched, let's patch the first, otherwise we need to copy it 3 times if we are unlucky. This is metadata. So then we probably need to check which the compiler might. Cargo, does it not have cargo tunnel? Ah, darn. I mean, maybe we, yeah, this is of course no worst case. I mean, which of them is used now? I mean, they're probably all used. What happens here is that different micro dependencies have different version dependencies, and then all of them are here. So it's like my mind is I understand the amazingness of the core principles. Recurrently, I was a great advocate of safer programming than C++ since the year 2000. Founded my company for better solutions and code that freaking just works every day. But this is just not perfect. It is not perfect. Is in my opinion already very nicely set to this stuff. I'm really sorry. So what we need, so they had in the other version, they had is64, and here's also MIPS. Not sure what they do with MIPS 64EL. Determined later. So is64 and India's little and machine EM. Okay, wonderful. We don't need this. We need is64, and we probably, so is64. Where is that? Okay, that is here determined from the ELF class. Okay, maybe we don't need to do that in this file after all. I mean, I hope it is easy. So the problem is, now I need to continue to review this code. As you see, all this offset sizes of and stuff are written in 60 or 32-bit, obviously, of all the segments. Write a section header. Yeah, this is somehow strangely. I don't. Because all the code is freaking like even this is not even very elegant. Even in C++, you could have a section header and a template with a section. You could instantiate it without duplicating. I mean, basically, all the code is duplicated. This is theoretically all the Rust people, but C++ sucks or Rust is amazing. And like, this looks like 100% code duplication to me. Okay, it looks like we might not patch this file after all. We might still in the other file find somewhere ELF class 64, hopefully. Yeah, maybe I should make a dedicated video and see how it goes, because this is basically the summary, and from now it only becomes a little bit more boring. So the problems are right. I think I searched it yesterday already. Basically, I did not find ELF class 60. Is it even the 64? So the problem is now, maybe I either halt the live stream, because you probably don't want to see me scrolling, grabbing and stuff through here. Maybe it is determined from architecture, because we have MIPS 64. I'm not even sure if it supports x32 then. Maybe it doesn't. So probably it's determined somewhere from MIPS 64. The problem is, did I use read? Oh, this is actually, so what do we even, okay, we need, or can we map that to, I mean, it needs to be an ELF 32. So that is basically where they copied this, right? As you've seen, they've run GCC, whatever, and these are the values. This is the ELF header we're talking about, right? ELF magic, and then all the bit fields of machine and flex and so on. I mean, it is technically, the question is, do we make ourselves life easier? Does it just work if we do that as MIPS 32? Maybe it does just work then? MIPS 64 and 32, does it use 64-bit registers? So N32, so 32-bit ABI generated. Yeah, I knew that. So we have ILP32. So this is integer long pointer. Okay, we double the floating point registers and have a different argument register calling for higher efficiency. But it is running in 64-bit mode, I believe. This UX0 should probably... So they run in 64-bit mode with FR1, floating point registers 1, for all the floating point registers. So it's running in 64-bit mode. I mean, yeah, I mean, that is the stuff, right? I mean, yes, it is a tricky ABI for obviously high performance 20 years ago on your supercomputers, like how you do even today. I mean, technically it is MIP64. It is probably it's really tricky. Where do they assign the let architecture, endianness, binary format, file. Okay, they have, this is a generic object writer that also can do COF and Mako or Mako. So where do they, so okay, they do here write object new architecture, and okay, they have here architecture from this architecture there. Maybe if we here I mean, this is just a bloody ELF writer. Maybe we can, I mean, it's probably relatively low tech of just stitching all the concatenating relatively simple, all those ELF files together. Hopefully the question is, actually here they also do tricky stuff. arch if pointer with, actually they have here some arch ILP32 architecture. Look at that. So the same craziness exists for ARM, which I believe very few use. Comment below. Even I have never seen that in public. Leave me in the comments below if anyone. Maybe some embedded stuff, gaming console or whatever. So actually they have that. Actually here they support. Actually here they support that. Here's X32. Actually, I wondered half an hour ago. So basically, where would they have X32? Only it duplicates the... You know what, let's grab for that. So what I usually do is then grab for something uncommon. And so where was it? Fix file in vendor object probably. And then I check what they do there. That is, I've found over the years the most efficient thing in other people's code bases. Yeah, so it's due to that nature. I mean, let me think. Maybe it is still easier to override the architecture. The question is also, where is it coming from? From where is that defined? I don't, or is that in... Yeah, the architectures. Allow non-camel case types. Oh man, I really don't like what I'm seeing. You can, yeah. The question is, I mean, we could quickly see, also it's getting a little bit fresh for me. There is a t-shirt in the spring weather. probably not the best pro tip for the Berlin spring today. We can quickly see how many cases that would affect, I guess, MIPS 64 non-camel case types. How is that non? Because it has an underscore, or why? Probably crazy shit. We could name it the same and see how many places we need to adapt. And the problem is now we have 3 copies of this bloody object crate there. Okay, that actually didn't... Why is it not warn? Should it not freaking warn all over the place that this is not handled? I'm actually... That is suspicious. Actually, yeah, we could do this target pointer with. Actually, you know what? We could. You know, let's not make it so complicated. Let's reverse that here because I don't want to adapt so much code. Let's try to quick hack it for a test to even see if that even works. Let's target pointer with, that should be valid. Let's overwrite this here to if session or whatever that stands for, pointer with, wait, I do this in the wrong one. Very clever for me. Let's overwrite this to MIPS for a test. It's really verbose. I mean, we're in C, you would just this or that. It's like, yeah, I'm not sure if you can do it. Just don't know each trust detail. Oops. The only problem is we need to adapt this here. So that is, I mean, at least the other stuff here would be working. Let's just hack that for now. I just want to see if that has a chance to work. Because I don't know how many other dozen of places we need to touch. So that is ABI2, I believe. Took me also a while to Google this stuff. I thought it's ABIN32, but it might be ABI2. So we need cpic, pic. Do we have pic? Cpic, pic, ABI2. This non-stuff. Oh, here's pic. Not static, then pic. I was actually also missing here. It's probably also incomplete. You would think you would. It's like why duplicate the code like this? I have no idea. So it might actually have a chance to be usable like that. Let's see what happens. Arch, cpic, pic. Let's see what happens with that. Multiply possible tokens in 116. Alright, they don't want. Yeah, the syntax here sucks. Also kind of, yeah. It's amazing, except when it isn't. Did this really go further, or is it still... Oh, it's building... I'm slightly wondering if it's already going further, because before it did error out instantly. So maybe that did something. Maybe that's already matching enough. So yeah, theoretically, yours truly could get... I have already contributed to the RISCV compiler. That could be the next more significant change of actually fixing the bloody MIPS support. You can't make this stuff up. But and also what I really wonder is that other people don't do it more. I mean, I understand people don't know what they're doing and stuff, but this code is really low quality. I also wonder how this passes AAA Rust code review. If I would be the Rust compiler engineer and would look at this, or any, obviously not the main person, hey, release build completed successfully, yay! So this is of course a quick hack. This is by no means how I would submit it upstream and how it obviously would not be accepted. However, and so yeah, it's ideally we should probably introduce an underscore ILP32, assign that there, clean up the whole MIP64 thing there of not having everything hard-coded there. Very theoretically, you could even unify that like RISC-V. That probably would be the best thing to do, although it's a little bit more flex. And in general, the whole code should not be written like that, in my opinion. But that is another thing. Plus, they should reuse the metadata from the input objects. But what do I know about computer engineering? I'm just some infamous YouTuber who doesn't know what he's doing. Let's see how much more stuff of this stuff builds. So let's hotfix MIPS 6, or maybe hotfix ELF object, or object writer, ELF object, ELF, yeah, whatever. And 32, I just collected different patches. I don't YOLO everything in one patch, unless they become 100. But then you have one small patch for one small thing. That is, of course, I need to, yeah, I could do that now, but that would be another hour. And yes, this small code, like, especially if you unify all the MIPS case, architecture case here, that would be even more work of also because testing. But I should do it because who else will otherwise do it? Let's build that and see how much more stuff built then. Also, let's actually, oh, this also doesn't apply because some reason. It is possible that I had here already other pre-patching some. Ah, this probably. Yeah, that obviously conflicts, and this we can also clean up because we probably don't need either of those. Now that we know how this works, I believe that should. Ah, yeah, this ABI 60. Why did I have ABI 64 here? All right, I know this is. But wait, what do I? Wait, what? This is confusing me. We double patched that. Yeah, so I had ABI N32. So GNU ABI N32 works. I don't know if both work, but I believe from yesterday's investigation, LLVM is using GNU ABI. And if the other works, then only by pure chance and accident, not necessarily by design or by pure luck and whatnot. So did I modify probably features? That is, yeah, I need to at least, now I modified that. 1, 2, 3. This, because we delete features here. From the original patch, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and yeah, this should probably be 15. If I didn't miscount now. The only thing is the other patch will now not apply. That is hotfix ELF MIPS. because we just modified it, probably. Yeah, now this will not apply anymore. So do I still have this on the scroll back? Of course I don't. I mean, it's not this part. This part wasn't working. We can also delete it. The only significant thing there. I mean, we have this prototype in the other case. Yeah. So that we anyway need to rewrite it, because of course we do. Let's see how many other changes. So yeah, another significant contribution to open source stuff that's of course not done. It's also documenting, like, it needs a debugging process, right? Even if it's in the end only a dozen lines of code. I spent probably now soon 3 hours plus. So like easily 3 hours, especially like if I now finish another 30 minutes or stuff. Leave me in the comments below, shall I subscribe if I should do all of this stuff live on YouTube. In general, I have the impression the longer the videos, the less people watch, and that is of course a problem. Then we need, this is, okay, I deleted apparently the Rust stuff already, but at the end we want, for example, thin provisioning profiles, which now is using Rust. Thin provisioning profiles, oops. Yeah, I could also should have built this verbose, but I recurrently forget. Let me just wake up data. Ether wake there. Login, which that is that idea. I probably should also give my machines here better DNS names. Oh, come on. Why does it take, is it even, or oh wait, this is the wrong IP. Of course it is. So yeah, let's run data to get the latest upgrades of the day. And yeah, then let's see. So we need, I believe we only need one Rust, that is a cross compiler. Then natively, I mean, the tipping point of this would of course be recurrently the first live on YouTube and in the world running the Rust compiler natively on our precious dual processor SG Octane. Previous video. Not to mention my O2, but my O2 needs more. My O2 has an R12000 processor that's not stable with Linux. I didn't even got Linux booted there yet, although it theoretically should boot, but yeah, that is another story for next year, or when I retire eventually. Of course, we will have, just because maybe when we open our computer museum here in the heart of Europe, latest then eventually we will run T2, of course, or I need another non-R10K system board for the O2 that although I believe the issue with booting my Linux on my O2 is probably in generic, because the reports are R10K, R12K are unstable, but they should boot, and I didn't get to boot yet, so there is some more major thing going on. But that's of course not the priority. We anyway have an SJ Octane, like of course like professionals do. So that's enough for me to test with these days. Yeah, when this builds, then I probably, I mean, the chances are probably 50-50 that this just works. Thin provisioning tools. No, I don't have Rust yet, just wanted to type that already. But that would of course be the next thing. That this also works. I mean, we are obviously not yet running Firefox where we would need Rust. You might be wondering, why do we even bother with Rust on MIPS64? Although theoretically you could still run MIPS32, R6, whatever, on your next access point and Wi-Fi router and so on, or switch, network switch and so on. Maybe one day I should get this, what are they, KVM? Where's they named? Yeah, Octeon, yeah, KVM. Maybe one day I should get my latest and greatest, yeah, before they switch to ARM, for reasons I totally can't understand. So yeah, thin provisioning profiles. I built Firefox before Rust 2 or 3 years ago for MIPS, and it unfortunately segmentation faulted and created probably an over 1 gigabyte sized core dump, so thank you very much. But that is next on my to-do, getting Firefox actually not segmentation faulting on PowerPC, or potentially MIPS or Spark. Ironically, Firefox on Spark did work not too long ago, like 2 years. Was it with Rust? The thin provisioning starts compiling. The question is, does it link and work? I just pre-run this because the build now builds Cargo and Rust, like the Canadian cross-compiled native Rust compiler then. I mean, it builds surprisingly long. So, we could, even if it even builds, of course we will check, like professionals do. Recurring theme here, what's not tested is broken, so of course we test it. That would be first checking with file or read elf the elf magic and stuff, that it's really MIPS 64 and 32 ABI binaries, and then trying to run this in QEMU, but yeah, of course it, as expected, that would have been too easy if it just worked. File in wrong format, that is, wait, why is this, strange. Rust itself did work, and this doesn't? This has the same issue now. How is it possible? Is this... I mean, it's not yet necessarily... it looks like the same, though. That is peculiar. Then this is also why I built that first, before even doing more, because before that is proven to have a useful effect. Why is this not... Ah, the other was too big. This is tempfs not keeping tempfs on error. Okay, Rustix also fails here. Why does this fail like it just failed before? Which did we patch? We patched the compiler metadata. Rust itself built. Yeah, so much to, did I say 2.5 hours to 3, 4, 5 hours. It's nothing like figuring out what's freaking going on here. Did we have that? No, we also didn't have that. Why did it build now? What the heck? It just failed a second ago. What? What the heck? Heisen build. It's not a Heisen bug, it's a Heisen build. Can't make this stuff up. Okay, it built, to my surprise. Maybe we should rebuild it. But that is bizarre. Thin provisioning profiles. It installs, for example, cache check. That should be in... Is it here? Cache check, cache. No? SBIN, of course. User SBIN? Hello, you had... How did we break that? Good that we checked that. pdata tools. N32 MIPS 4 version 1 sys5 dynamically linked interpreter lib32ld SR Linux 32 stripped. Okay, but cargo still fails. Ah, wait, this could be the same. It could be the same RISCV stuff from yesterday, although it's MIPS, but because on a first glance, yeah, of course it's this yesterday. Und grüßlich, what is this movie? What is the freaking English title of this movie? Okay, original Groundhog Day, apparently. It's like, yeah, probably recurring theme, Groundhog Day. Fixing again every day what we just YOLO'd and correct yesterday for RISC-V. Today for MIP 64. Yeah, if you don't stand on this happens, ladies and gentlemen, that is if you not invented here, not implemented here, not standing on giants. That is what you get if you discard 30 years of proven, I mean, not saying that C is amazing, but hey, at least maybe you should generically C bind gen all this stuff from system headers and not hard coding convert. I mean, okay, it is generated with C bind gen, but I would be slightly curious. Now let's dip cargo for a second. We know how to hotfix that from yesterday. Let's see what happens with a Canadian cross-compiled native Rust thing. Yeah, leave in the comments below. Do you want to see actually cleaning this up for production ready? That is easily another hour of. I mean, it looks simple. I mean, maybe it's only 30 minutes, but I'm getting tired of these errors. How's even this book? Speaking of tired. Yeah, so if first 2 seconds review of Maria Aceria Mark Stetter. On a first glance, looks useful. Obviously I didn't buy this for me, just here for our office library, creating one of the most amazing companies in the world, and just having good books standing here. Obviously you see me recurringly, hey, system calls page. Speaking of which, hard-coded cargo and stuff. Page 75, chapter 3, OS fundamentals, system calls, and what is can we also focus that and white balance and stuff. Yeah, NR write V and stuff, just what is missing there in cargo's snowflake system calls. So yeah, we have fixed another thing live on this channel. I hope you are as thrilled as I am about our increasingly everything just works, or even if it's just hot fixed and hot quirked live here on this channel. These should be computer museum meetups where people bring their ancient hardware running latest software. Probably, I mean, kinda vintage computing festival, right? I was 2 years or 3 years ago. In retrospect, I should have gotten there last year. I somehow missed it. I basically saw like on someone's Mastodon, hey, vintage computer festival stuff, and it's like yesterday. It's like you could have gone there even with my 3-year-old, obviously. We also actually did that at Rock Linux, right? T2 is our amazing Linux distribution, success for Rock Linux, where I was stable release maintainer, major contributor and stuff. We did this basically at the Chaos Computer Congress, Chaos Congress, Chaos Computer Congress, CCC, like 2001 to 3 and stuff. They even then, Rock Linux developers would have brought their SGI Indie, for example, I remember, or just Transmeta. I mean, not that vintage, even back in the day. I mean, it was out of production. I mean, no normal Linux hacker brought their SGI Indie. So I haven't asked where they go. I mean, but there were some people, for example, we had some Sun Spark fans before I had one. That's also how I got in touch with all this stuff. And one guy there had mountains of Spark stuff, but he also did that professionally, right? So as a day job, he was installing, maintaining and stuff for big mega corporations, the Spark stuff. So he had probably like last year's production phase out stuff, always mountains of. But the other one was just a student like me with his SJ Indie, so friends, family, eBay, I don't know. I got my SJ Octane much later, relatively affordable actually, but it was still quite some years when I had already forked T2. It was probably 2005, I believe, when I got my my first SJ Octane. Cheapish on, I mean, 100 whatever euro, whatever. It was, yeah, cheapish, but yeah, it was obviously not a practical machine. I was surprised, I said this before, I was surprised how big, heavy and loud it was. And it didn't even work the most flawlessly back in the day with Linux, unfortunately. So it was for years quite heavy, paperwhite. So yeah, Rust, the Canadian Cross Rust-C built surprisingly long there. Let's actually see if the segmentation faults or not. All right, we also need to fix this. So this means that we need to rebuild all. That is also another win-win, right? Not only telling you my life story and fixing state-of-the-art Rust stuff here, or not yet really. I mean, the code was shitty to start with. I mean, how shitty I fixed it for a proof of concept test. Yeah. We have some GoFundMe, right? GoFundMe. I mean, it says P3 and stuff, but basically keeping all the shit working on the architectures. You're welcome, because 169 euro already spent on making P3 patches better. So need more funding for making MIP64 and RISC-V better. Package and coffee. Package, thin, oops, fat fingered that as usual here. What have I done here? Cross warp and neck and stopped. Destier. Probably this Destier. Why did I even have it in there? Probably that is how I... Or, you know what? Maybe they changed it. I don't believe I was so stupid to do it unintentionally. Wait, well, make install should have that in already. So yeah, probably they changed it upstream, because I have it hard to believe that I didn't notice that when I did that. So we need, unfortunately, so I probably... Hola. There, and welcome everyone. Happy that you tuned in and that you are here and a subscriber. Okay, still building. So yeah, we need for all, basically for be in all builds, do mine root brf thin provisioning tools done. I probably why did it move that to backup? Whatever. Remove all the log files in var adm log. I should automate that in some way, shape or form. And then let's test that again. Let's hope it builds a second time, because some of the first time it didn't. So whatever was wrong there. And you know what? I need more coffee. I deserve even. I don't even need. I deserve more coffee for fixing this shit. Yeah, no idea what was the first time, so then it looks like Rust is still being. When we have proven that Rust Canadian cross compiles, and we will do the other thing. So let's see, MIPS64 user sbin cache check. So how to run this is usually QEMU MIPS N32, I believe it was -L. And this is why I patched. So the upstream QEMU doesn't have this option, but our T2, everything improved and fixed to just work TM, has change road. And it works, I would say. So I'm thrilled. I'm thrilled. Ecstatic. That is the most amazing release of T2 ever, with this amazing RISC 532 and MIP64 support. Shall I subscribe if you agree? And I grab my coffee. And don't forget to Patreon. Yeah, will not be that we will be building everything natively on a SG Octane, because it would take a year or so with modern software. It's still building. Actually, we probably should word count how many micro dependencies Rust has in the meantime. As I said earlier, I believe 2 or 3 years ago it were 160 or 150, but in the meantime Cargo has already 161 or whatever it was yesterday. Hey, Rust freaking Canadian cross-compiled. Can't believe that. Build MIP64 QEMU user bin Rust. Where do we? Right, we install this to opt Rust. We installed it there. Everything major convoluting stuff I prefer. Personal preferences, it's just a T2 default. If you don't like it, you can reconfigure it. But I like my stuff a little bit sorted and grouped. Okay, that is not ideal. That is QEMU, whatever stuff. It might be fixable potentially with bin ld os bin ld config first. Does it work? Hey, then it works. Yay. It will probably not build something because it will probably want to spawn some CC. We could check this if we copy our MISC archive, but I don't have the highest hopes. The problem is that if you re-execute stuff in QEMU, then you get the native system call, and then you cross-compiled stuff. 1, 2, MISC archive, hello, Rust. But yeah, this will probably not work, but we can... Wait, did it even... I'm not sure, does it work with you if you just... Not even sure if that worked. No, segmentation fault. Yeah, it may or may not be QEMU related, but that's not what we are debugging today. I should not have tried this live on YouTube. You may or may not get a working Rust compiler on your SG Octane, but hey, at least some provisioning tools start to work. Probably should check if they... But yeah, software is complex. That is also why yes, not invented here, not standing on the shoulders of giants, why I'm tempted myself to reinvent a whole OS and compiler, because everything is just too large and too big that it fails. So that's it for this video. I have some code to clean up, some other implementation marginalities and imperfections to debug. L3P3 likes such story, fairy tales. Happy to hear that. I hope you enjoyed this and learned something. As usual, there is Patreon, GitHub sponsorship, or GoFundMe to fund all this crazy excessive work that I put into keeping the non-mainstream Linux ecosystem up and running. Hope you have or wish you a lovely day or night, and hope to see you soon for all the next fun stuff to come, like running it on real hardware. Warming up the Spring Office with an SG Octane.